I'd like to remind you that for more Microsoft webcasts, you can go to microsoft.com/webcasts. Thanks again for joining us for today's presentation, SQL Server Codename Katmai Data Management Overview. Now it is my pleasure to introduce today's presenter, Ram Ramanathan. Ram, you now have the floor.
Thanks, Heather. Welcome, everybody, and good morning. I know it's pretty early in the morning for at least for the folks in the West Coast. SQL Server 2005 has had incredible momentum in the marketplace, powering the largest enterprises with a secure, reliable, and scalable platform. SQL Server 2008, formerly known as SQL Server Codename Katmai, continues to build on the momentum of SQL Server 2005 by providing an even more scalable platform, enabling you to put your biggest and baddest applications to run on SQL Server. Today, I want to take the opportunity to talk to you about the key innovations that we will be covering in SQL Server 2008 in the area of data management. We will be talking about some of the new innovations that we are making in SQL Server 2008 in the area of security, high availability, performance management, and manageability. And of course, we want to talk at the end of saying can we expect all these innovations coming in from a SQL Server 2008 perspective. Before we move on to the actual product of SQL Server 2008, I want to take the opportunity to talk to you about the overall vision that we see in the data management arena. One of the aspects that we see is we believe that we are in the midst of an information age explosion. We see a proliferation of new kinds of data coming into the marketplace. We see the digitization of existing information, whether it is videos from sensors or whether it's RFID tags from your shipments inventory management systems. And managing all these different data types in a single and logical manner is becoming even more difficult for you administrators and for developers. At the same time, we believe organizations and end users want to consume this information in a variety of form factors, whether it can be a mobile device and where they want to take the information with them on the road, or it may be in the local desktop, or maybe within Microsoft Office. How do we provide them with the information in the area that they want, within the application that they want to consume it in? Given this area of increased data and users wanting access to more information, we also need to be balanced against the increased regulations from whether it's SOX or Basel II, and how do we now need to provide a more secure and protected access to your information. At the same time, globalization is driving increasing availability and is diminishing our existing batch windows and maintenance windows that we are used to. Given this confluence of factors, how do you then provide a more secure, manageable platform? When SQL Server began when we started the planning for SQL Server 2008, we looked at all these different factors, and we believe that we can provide your data any place, anytime. Your data can be just relational data or non-relational data, whether it's in the form of XML, which we introduced in 2005, or multi-dimensional data that we have introduced in SQL Server 2000 or SQL Server 7.0. We are going to expand on this concept of your data by providing a framework for you to manage any kinds of data, from documents and images to geographical information, with a single logical model for you to expose this data. We believe that with the concept of entity data model, which we will be introducing in SQL Server next generation, along with the .NET framework, we can provide you a logical model to work on any type of data. And built on top of this model is a set of rich services that allows you to interact with the data, whether it's reporting, analysis, integration, or existing services like query, synchronization, and search. And of course, this data and these services can be deployed either in your data center or in your mobile devices, or actually in the cloud over CloudDB. So given our framework, so we believe in four core pillars of the SQL Server platform. We believe in providing a mission-critical platform that is secure, available, scalable, and manageable. We believe in providing a data platform that can manage more than just relational data, as I mentioned, but also non-relational information. We believe in providing a more powerful, integrated development environment that allows you to accelerate the speed by which you build applications and also reduce the complexity of building applications. At the same time, we want to be able to end users to get answers to the many questions that they now have given the explosion in information. And we believe in providing a scalable and a complete business intelligence platform, all integrated together. Given this vision, how does SQL Server 2008 deliver on this? We believe in providing that as I mentioned, there are four key pillars on enterprise data platform: dynamic development, beyond relational, and pervasive insight. In the enterprise data platform, which is what we will be covering today, we believe in providing a more secure and trusted platform for your data, which allows you to actually bet your business on a more secure platform and a reliable platform. At the same time, we want to reduce the time and cost of managing this infrastructure with a new innovative policy-based management infrastructure that we will be introducing in SQL Server 2008. Given the manageable, secure, reliable platform, we want to increase the scalability of the platform by providing a more predictable and optimized system performance. In the other three areas, which we'll not cover today, but we should talk about, is in the development area. We are making a significant investment in raising the level of data abstraction that you need to work with data with the introduction of the Entity Data Framework. We'll also be working on synchronization of your data from anywhere, enabling you to take your data with you on your Windows mobile devices, at the same time making sure that we can synchronize changes and updates and deletes to your backend data store in a disconnected manner. In the beyond relational, we're making a significant investment in moving the management of database from just facts and figures to sights and sounds, with the introduction of new kinds of data types around file stream and spatial data. We're delivering new types of spatial data types within the database in the form of geometry and geography data types, allows you to bring geographical information within your applications. In the business intelligence space, we are making a significant investment in data warehousing. We are already one of the fastest growing data warehousing vendors, and with SQL Server 2008, we believe we can raise the bar and now manage the largest and the biggest data warehouses in the world. We're also increasing the scalability and performance of a business intelligence platform within analysis services and reporting services to make it a more scalable and manageable BI platform. At the same time, as you scale and provide a more performant platform, we want your end users to interact with your data within the tools they are most familiar with. With SQL Server 2005 Service Pack 2, we have made great strides in integration with Microsoft Office, and we continue to build on that momentum in SQL Server 2008. You will see advanced visualizations and closer integration with Microsoft Office in SQL Server 2008. Given this context of the four major pillars, I want to now transition and talk about how do we provide a more mission-critical platform for your applications. This is a quick snapshot of just a sample of the features that we have in SQL Server 2008. I will not go through every feature, but I would encourage you in the end of the slide deck to talk to you about resources that allows you to learn more about the features we have. As I mentioned, in the era of globalization, we are seeing more and more organizations moving to 24/7 availability. Companies are slowly reducing the time for their maintenance windows as users across the globe need access to the information at any time of the day. Given these expectations of higher availability, we're also faced with additional security and privacy of information. We've seen the importance of privacy of your data that you store within your databases and how we need to make it secure against prying eyes. And at the same time, this data needs to be stored in compliance with increased regulations on how the data should be stored, how the data should be accessed, and how long the data must be stored. Given these challenges that information technology faces, SQL Server 2005 has already built a very sorry, let me build the slide up. SQL Server 2005 has already built a solid foundation on which SQL Server 2008 enhances. We provide a secure configuration, rich authentication of your users, granular access control, making sure the right people have access to the right information. At the same time, ensuring that once data does leave the database, it is encrypted and keeping protected from prying eyes. We also have increased auditing in SQL Server 2005, enabling to simplify compliance with increased regulations. Given this trustworthy platform in SQL Server 2005, SQL Server 2008 takes the next strides in this area. We want to protect your information with transparent data encryption that allows you to encrypt your data within your existing application. And we'll talk more about transparent data encryption in the next slide. We're also increasing the concept of external key management, enabling your existing applications that now have security keys to conform with the overall data center, where you have a single key manager. We're also significantly enhancing our data auditing capabilities, enabling you to answer common auditing questions such as what data was retrieved, and providing a higher level of storage of your compliance information to your auditors. We continue to invest significantly in the area of high availability. We have made significant investments in database mirroring, building on the momentum of 2005, and providing a more enhanced database mirroring for your most mission-critical applications. We're also adding the ability for your applications to add system resources on the fly with the ability of hot pluggable CPU. SQL Server 2005 already has the ability to increase memory on the fly, and SQL Server 2008 continues on the momentum by introducing the capability of adding CPUs. In the existing applications in transparent data encryption, one of the things that we have seen is as customers begin to encrypt the data in your database, our customers have had to rewrite the applications to take advantage of this functionality. With SQL Server 2008, we build on the momentum of 2005 by introducing transparent data encryption. This enables you to encrypt your information inside the database without requiring an application rewrite. And applications can provide the same level of functionality, whether it's indexes, whether it's range searches, or whether it's equal searches on your data. So this allows you to provide a higher level of security to your applications without in a seamless manner, without affecting your applications. On the availability side, SQL Server 2005 has significantly raised the bar in providing a highly available, always-on solution. Whether it's the online management of system resources, introduction of altered indexes with SQL Server 2005, or whether it's a logical recovery from user or application errors in the concept of log shipping, point-in-time snapshots of your data, or tracking history of DML statements. We also introduced database mirroring with SQL Server 2005 that enables you to take a snapshot, enables you to create a backup mirror of your database and provide a just-in-time functionality on your data. We've also introduced geographical dispersed systems, allowing you to create a mirror in a geographically dispersed data center, providing a higher level of disaster recovery. In SQL Server 2005, we introduced database mirroring, and I just want to walk you through how database mirroring works. In a traditional database and mirroring environment, a client makes a transaction that introduces a commit. This data is then returned to a log file that's also at the same time transferred to the mirror to write to its log file, so the data is replicated in real time, or in asynchronously also. In 2008, we continued to build on the momentum of database mirroring by introducing significant enhancements. We're increasing the performance and functionality of database mirroring by compressing the log stream between the principal and the mirror. This provides a higher level of performance for your high-performance applications. We also enable faster recovery from manual failover by avoiding an internal database restart, which occurs currently in 2005. At the same time, we've increased the investment in database mirroring by enabling you to automatically recover from storage failures in your backend hardware systems. And I will walk you through the demo of this in the upcoming slide. I just want to make sure that you guys have a snapshot of my information. Okay. I'm assuming all of you can see my management studio here. In this management studio, we actually have two different databases. One database is mirrored, and the second database is unmirrored. So what we have here is we want to demonstrate this capability of automatic page recovery. In both these databases, we have a table called customer. And let's go ahead and let me show you that table. So it's just a typical customer information. If you can imagine, it can be any application that maybe you may be using on the fly, which can be customer information. And again, please let the organizer know if you're unable to see the demo. I believe you should be able to. And let us double check to see if there's any suspect data pages in the database. And we see right now there's no corrupted information in this database. So what I want to do the next part is actually simulate a database corruption. And this can be due to a failure in your backend storage systems or in your backend SAN or a hardware failure in your existing servers. And let's show how our SQL Server database provides a higher level of availability in this scenario.
Excuse me, Ron.
Yep.
I'm getting a lot of feedback that your desktop is not updating for everyone.
Okay. All right. Let me put this slide. Apologies. Well, okay. Ah. Okay, you know what? I'm going to skip this demo. I can see that you're unable to see the demo on this thing. Apologies for this technical difficulty. But let us move on to the next slide. I'll try to come back to this demo in the. You guys just. I'll come back to that. I'll come back to the high availability demo at the end of the presentation. So just to kind of recap from a security and availability perspective, we're providing a significant set of investments around encryption, around availability, around auditing, and of course around the database mirroring and adding system resources. Now I would like to transition to talk about how we're going to provide a more scalable and highly performant database. When we look at performance management, we look at around 4 different pillars. We look at just raw throughput from providing a faster response to your end users and just adding more and supporting larger number of concurrent users. From a scalability perspective, we want to accommodate the growing data volumes, whether it's in your data warehouses or in your OLTP applications. At the same time, accommodating the larger number of users now use your applications. Given this trends of both scalability and performance, one of the things that administrators, as we listen to customers and listen to you, is customers now want a more predictable response from their end users. Is once you set up the system, How do we ensure that we get a predictable performance from the systems, whether it is across multiple different workloads? And at the same time, users want to be able to easily diagnose and troubleshoot problems that occur, whether it's hardware failures, I/O performance, or network issues. How do we provide a faster resolution to performance issues? In SQL Server 2005, we've introduced a variety of features, and this is just a snapshot of them, a small subset of them, whether it's improved table and index partitioning, enabling you to manage larger number of tables in smaller manageable chunks, scalable and high-performance query processing, and of course, simplifying aggregations from a data warehousing scenario, whether it's using index views or aggregation management inside analysis services. We've also significantly improved our index management capabilities in 2005, allowing you to match those trends around disappearing or shrinking batch windows. And we also introduced significant new capabilities around backing up and restoring data and making sure we can just do that for active partitions alone. SQL Server 2008 continues to build on that investment by providing a optimized and predictable performance. And we're covering that in 5 major areas. We want to be able to provide you significant capabilities around troubleshooting and providing you more enhanced system analysis tools in our performance data collection. This tool collects system information from across your database, whether it's your DMVs, your system and log files, or I/O performance from Perf Monitor into a single data repository, and provides a comprehensive set of management reports that allows you to report and analyze the information, your performance information. This allows you to create a benchmark of performance from week to week and enables you to analyze your performance over time. We built on a performance aspect by storing your data more effectively and efficiently with improved data compression. This not only reduces your storage costs by storing your data more efficiently, but also increases your I/O performance by now retrieving less data and less storage from your back-end storage system, and allowing you to use your in-memory much more efficiently. We're also enabling you to provide a more predictable performance with plan guides that allow you to take a snapshot of your system at any point in time, and then broadcast these new plan guides, whether it's to your production system or doing upgrades, enabling you to more efficiently upgrade systems from point A to point B without worrying about performance degradation. In the last, we introduced a significant new feature in Resource Governor that allows you to manage multiple concurrent workloads on a single system. And we will talk more about Resource Governor in the upcoming slides. In the traditional, in SQL Server 2005, we normally had a single resource pool, and we have multiple different workloads coming after the system. But for example, we may have a set of financial databases on a server which now serve multiple different financial applications, whether it's your expense reporting application, your timesheet application, or feeding data from this database to your CRM application or ERP systems. When all these different applications execute queries on the same database, we now lead to resource contention. In SQL Server 2008, we've increasing this ability to manage multiple different workloads by being able to differentiate between these workloads. And for each one of these workloads, you can then start defining request limits, whether it's memory or CPU or number of requests. And you can then manage these limits for different workloads. Of course, we automatically report compliance and making sure each workload only consumes the resources that it has been allocated. This allows you to prevent common data warehousing scenarios, for example, like runaway queries, when a person doing ad hoc analysis joins 2 large tables, and when they execute this query, it may consume all the resources in the database, shutting down existing running reports or feeding data from the data warehouse to your ERP system. And so these limit workloads prevent that from occurring. and also provides a more predictable performance to your users. Another aspect of resource management is priority. How do we make sure that, for example, in a data warehouse system that now supports a reporting application, ad hoc analysis, and taking data from the data warehouse to your existing ERP app? Obviously, your ERP app is a mission-critical application, and when it requires data from the data warehouse, we need to be able to make sure that we feed this data back to the ERP system as soon as possible. In this case, we want to set up a priority on the OLTP activity at a higher priority than your ad hoc analysis or your reporting. And SQL Server 2008 will enable you now to define priorities on these different workloads. Given these workloads, we also now need to manage the resource pools that these workloads can consume. For example, we may want to set aside 90% of the resources on your server for different workloads and set aside 10% of the workload for our administration tasks, whether it's index management, whether it's cleaning up the data files, work that a database needs to do on an ongoing basis. This allows you to continue to operate on your administration without bringing a database. And when you bring it all together, we can see that you can continue to execute the admin tasks on your administration pool and execute your OLTP activity and your reporting on your application pool, separating out the two different activities in different resource pools and providing a more predictable and manageable response to your different applications. And let's talk about how these different functionality has also been enhanced from a data warehousing scenario. Within data warehousing, we have significantly enhanced the capability of the relational engine in partitioning. We have now improved partitioning to handle larger and bigger tables with improved partition table parallelism. We've also introduced new kinds of data warehouse query optimization in the form of star join queries, enabling you to support common data warehousing scenarios where in a star schema we're able to now join a dimension of fact table more efficiently. As I mentioned earlier, we're also providing a higher level of I/O performance with efficient and cost-effective data storage. With Resource Governor, it enables us to manage multiple concurrent workloads, whether it's ad hoc queries or reporting and analysis. At the same time, given this ability to manage large number of users and data, we're also enabling you to integrate this data into your data warehouse much more efficiently with a highly performant ETL engine and SQL Server integration services, and introducing new functionality around change data capture, which enables you to capture your operational changes and just feed those changes to your data warehouse without significantly altering your store schemas. We're introducing new kinds of SQL statements, whether it's merge, SQL statement, and new kinds of profiling capabilities. To wrap up, what I've gone through is talking about all the different functionality that we are introducing around data warehousing, whether it is ability to manage multiple concurrent workloads, or whether it's just query performance with partition table parallelism. So we've now talked about availability, security, and performance, and now I would like to transition and talk about how do you then provide a management framework across all these different functionality. You know, as I say, people don't scale, but they let me build the slide up. One of the things that we've seen that is the things that you need to do around whether it's focusing on doing day-to-day operations, whether it's having to focus on setting up a new set of policies that you have to put in place across your organization to manage your different configurations, or whether it's making sure that the database is deployed more securely across your organization. SQL Server 2005 has provided a rich set of functionality for you to install, configure, upgrade, monitor, tune, maintain, and uninstall your system, so providing a secure, comprehensive set of functionality across the entire life cycle of database management. SQL Server 2008 builds on that functionality we're providing a more innovative policy-based management infrastructure. And let's talk about a little bit of what do we mean by policies. Policies are a set of things that you would want to put in place, whether it's a set of defining a configuration for your development environment or a different set of configuration for your production environment, and rolling out this configuration across all your different servers within your system. You may have a set of configuration that you may have for all your financial applications, and you can then deploy the set of configurations, whether it's naming conventions, best practices, whether it is around database options. Once you define this set of configurations, you can then make sure all financial databases conform to this configuration. We're also providing functionality around server group management, which really means that once you define a set of configurations, we allow you to distribute that throughout your organization. And of course, all these policies and this infrastructure is existed with your and integrated with your enterprise system management with closer integration with Microsoft System Center. As we started going down this path of policy-based management, we've seen, some of the challenges that we have listened to customers telling us is around as we increase more and more product capabilities, it increases the number of knobs and switches that the DBA now needs to manage. And one of our challenges and trends that we want to tackle for SQL Server 2008 is how do you minimize these knobs that DBAs have to deal with, and how do we abstract out and provide a higher level of functionality for DBAs by providing increasing level of functionality underneath the covers. Another part that we have continuously seen is DBAs now need to manage multiple different databases within the organization. And how do we scale a DBA to now provide a set of tools and make their life easier so they can now manage multiple systems without being in a fixed amount of time. And given the fact that applications are becoming more and more powerful and storing data locally, how can a DBA now manage data more securely when data is now distributed across the enterprise, whether it's on your device or on your desktop? So we now need to provide automated controlling and monitoring of your policies that you define across the enterprise. Given these high-level trends, SQL Server 2008 provides a comprehensive policy-based management infrastructure. Let's take a look at some sample policies that you may define with SQL Server 2008. For example, you may want to provide a more secure configuration for databases that you implement in your system. And we do that by you may define a set of surface area configurations that you may define. For example, you may want to disable SQL CLR, or you may want to disable database mail in most of your databases that you install within your system. So you can define a policy around security. You may have a trivial policy around naming conventions. For example, you want all databases and to have tables named ending with TBL. Or you may want to define where databases can be, what database editions can be installed within enterprise. And for example, you may define only developer edition is allowed on developer workstations and preventing developers from installing enterprise or standard editions across your enterprise. Let me now walk you through a sample demo of policy-based management infrastructure. I hope that you're now able to see this demo.
Ron, what are we supposed to be seeing?
You should be seeing SQL Server Management Studio.
Yes, and it says test 2.
Yeah.
Okay.
Perfect. Okay. So one of the things that you'll notice in SQL Server Management Studio is this new aspect called policy management. Within policy management, you can create a new set of policies, conditions, and facets. And let me walk through that and give you an idea of what I'm talking about. Let me go ahead and create a new policy. In this policy, I want to start out with something very basic, and I'm going. Yeah.
Sorry, I think we're still not seeing any updates.
Ah, okay.
You might need to log back out or log out and log back into live meeting.
Let me do that. I'm assuming now you can see this new create new policy.
Yes.
Okay. So in this policy, I'm going to create a very basic policy around naming table naming conventions. So let me just call it naming conventions. I've now have it says obviously that there's no condition applied to this. Let's go ahead and create a new condition. And this may be a financial naming policy, financial name. And the facets are different parts of the database that you want to manage. So in this case, for example, as you can see, you have application roles, where there's database facets, index facets. There's a comprehensive set of facets here. And of course, what we will do by the time 2008 will be released is making this an extensible process where ISVs or DBAs themselves can create new kinds of facets to be incorporated here. What I will work on is creating this thing called multi-part name facet, because I want to create a naming convention. And I will use a name. And I'm going to call this, I want all my thing to begin with FinStar. A simple facet, I want all my financial tables to belong with FinStar. So I'm going to save this. And of course, the next thing it's going to ask you is, where should I now apply this facet across? So obviously, since it's a naming convention, it has a wide variety of targets that you can apply this policy to. And all I'm going to choose is a table, because I wanted this to be a table naming convention. Another part it asks is, what groups should this policy be applied to? So there are two cases. A default policy means that any database in your organization will have to conform to this policy. But in this case, what I want to do is actually create a new group called financial group, as I want only databases in my financial group to conform to this policy. I'm going to create that. Another part you'll see is execution mode. So execution mode is 4 different cases. It can either be on enforce, which we can do for policies in case of DDL triggers, for example, like on a create table or create view, alter table. So for those policies, we can for those kind of operations, we can automatically enforce these policies at the time of execution, preventing some person from doing the bad operation. We can also do check on changes when something happens, trigger off and making sure the policy is run on that. Or you can do check on schedule. In this case, I want to go ahead and click on enforce, but I want this policy to be automatically enforced. I still haven't enabled that just to make sure. So let's go ahead and let's run something here. So I'm going to create a new query on this test2 database. And it's a simple query, and I'm just going to do a create table, test1, sample call it int. And obviously this table fails our naming convention, but I still haven't enabled the policy. So as you can see, the table gets created successfully. Now let us go ahead and enable this policy. And let us go to my database and now subscribe to this policy. So this shows that you now have naming convention passed on to you. So now let's go back and try to create a new table called test2 with the same kind of naming convention. And what we want to occur is actually for this query to fail. So when you execute this query, you can see it's executing, it's running in the background. Just so I'm not lying, I can show you that it is executing the query in the background. It's going to go. The reason it's bringing it up is the first time I'm clicking a policy. But what is shown that it's actually gone and prevented this create statement from executing by saying this policy has been violated. So this allows you to actually prevent an administrator or a DBA from doing the wrong action in certain kind of scenarios. What I want to do, the next policy is actually create something where you may want to define a configuration for your database options. So let's go ahead and create a new policy here, and let's call it DB configurations. I want to create a new set of conditions, and these can be DB configs, financial, DB configs. And this is going to be on a database facet. And so database facets expose a set of properties about the database. And some of these properties that I'm going to work with is around auto close. For example, I want auto close to be set to false in most production systems, because we really don't want the database to close a connection after the last user is executed in production systems, because we always want to provide a high level of response to end users. And we may also want to do something around auto update statistics, because again, in the production system, we may have a batch window where we want to execute these statistics, or have a set of jobs that you already define on when to update statistics. So let's go ahead and set that to false, and let's click OK. And of course, this is now going to ask you what you want to apply it to. It's a database facet, so most probably the target would be a database. So let's go ahead and apply to that. I want it again belong to the same group called financial databases. Of course, keep in mind that if it's set to default, that means all database will now adhere to that. And I want to check it on schedule. So I'm going to create a new schedule called minute schedule, recurring. I want to do it daily. I want to do it daily. I want to recur. Because every minute. And we'll set it up. So that's it, and I've also enabled that. So now if you go back and if you give it a minute while this is running, it should automatically come back. Let's close that and refresh. Let's refresh this again. You know what? I'm just going to let's do this again. Sorry, I just want to make sure you see that. And as you can see, this database actually now fails this policy, because if you bring up the database, if you go to options, we have now actually defined auto close to be set to true, and we want auto update statistics to be set to true. But what we can actually now do with policies is actually, if you now bring up the policies window, it has failed. Let us go ahead and run this policy. Database configurations. And if you go ahead and check, it's going to come back it's failed. And now you can actually set it to auto configure, which actually now goes and fixes the database and makes the database now conform to the policy that you have defined. So if you go back and open up test, and you look at your options, you now see auto close set to false and auto update statistics set to false, which is what we really wanted to be in the first place. Okay, so now let's go back to the console, and let's go back to the next slide, which is our release calendar. But before we do that, let us now see if I can actually now run the database demo for you guys. Okay. So I need to back up. This is a high availability demo, which I spoke about earlier, and I had technical difficulties. And so now let's talk about this high availability demo. So what I have here is two databases. One database is mirrored, and one database is not mirrored and not using database mirroring. Let's go and use the not mirrored database here. Let's go ahead and retrieve some data. We can retrieve data efficiently, no problems. And let's make sure there's no data corrupted in the system. And we can see there's no database corrupted. Now if you go ahead and execute a corrupt page, and what I'm trying to do here is actually simulate a hardware failure. It can be either your SAN going down, your storage infrastructure dying, or even somebody just pulling the cable out of the SAN, right? A whole set of hardware problems that can occur. And this is going to cause a database corruption. And now if you try to retrieve data from the customer table, you're actually going to get an error message because now the database, the table is actually corrupted. So if you now think about it, the application that is using this data is actually down. No one is actually able to retrieve information from the system, and no one's actually able to, and your business is down. So if you now execute this query, you can see there's actually now a corrupted page in your database. Now let's move on to the database mirroring scenario. I'm now in my mirrored database, and let's go back into the same system. Let's make sure there's no databases, there's no corrupt pages. Let's make sure we can continue to retrieve data from your customer database, right? So everything is working as it should. What I want to now simulate the same kind of hardware failure on my mirrored system. And let's go and execute that hardware failure. It's going to corrupt the system. And the first query in the mirror database is going to say, hey, guess what? The database fails, and you'll see that the customer information is corrupt. But what now happens underneath the covers is actually this automatic page recovery. So what we would do under the covers is actually talk to the mirrored database and retrieve the page that is now functioning properly in the mirror database and recover from the mirror and override the corrupt page in the principal. So if you look at the mirror database, we're going to continue to say that's a corrupt page. But if you now execute the query against the customer table, voila, the data underneath is automatically being recovered from your mirrored database, and your principal is now up and running and providing data to your end user application. So in this scenario, your applications are continuing to function, getting the data from the mirrored without requiring automatic failover, without without causing any downtime to your end user applications. Now let's get back. Now let me go back to the release schedule. So just as a wrap up, what I've done here is walking through the availability features, performance management features, a high level on the manageability features, security features. And again, this is just to give you a snapshot of some of the functionality that we're doing. I have not talked about a whole series of around the new kind of data types we're introducing, around the documents, around geographical information, new kinds of date and timestamps, sparse columns, hierarchy IDs. There's a whole series of features that I've not talked about, and we will be covering that in upcoming live casts. So just to give you a snapshot from a timeline perspective, we have released our first CTP in TechEd nearly 3 weeks ago, and I would encourage that you can now download over the web. We are in the process of releasing additional CTPs every 60 days, approximately every 60 days. So we'll add additional functionality to existing Katmai SQL Server 2008 CTPs. And we are now projecting a release date for SQL Server in year 2008. From a next steps perspective, I would highly encourage all of you to upgrade to SQL Server 2005 as soon as possible, because the upgrade path from 2005 to 2008 will obviously be much more seamless than from an earlier version of SQL Server. So I would encourage all of you to upgrade SQL Server 2005 now, so you can now upgrade 2008 in the future. I would also encourage all of you to learn more about SQL Server 2008, and I'll provide you a link where you can download data sheets, grab the white papers, look at additional webcasts. You'd also have the ability to download the latest CTP3 bits online. I'll also provide a link to you there, and you can actually download the latest CTPs. We also have live meetings on each of some of the key features that we introduce in CTP3 in the same page for you to learn more about some of the new features that we are introducing. With that being said, I want to then now take the time to answer questions that you may have. And let me bring up the question manager. Okay. So application pools. I think it is similar to IIS app pools, but I'm not that familiar with IIS. But I think it is definitely the question is, are app pools in concept similar to IIS app pools? That is a way of isolating app resource usage. That is exactly right. The goal that we want to do is making sure that each application does not consume resources that's been allocated to some other application. And the way we see that is enabling new kinds of scenarios in server consolidation and also around data warehousing. The next question is, what are facets, and also what are the steps to configure automatic page recovery? So let me first answer facets, which is the first question. So facets can be a certain, it can be an area that we want to configure in the database. In the demo I walked through, the facets are around naming conventions. Facets are around a set of database properties. It could be around a set of index properties. So it's really different parts of the database that allows you to manage, that provides a set of properties that you can now manage. So if you think about it, in the case of a database, the database offers you a set of options, and these properties can now be managed for that database. In the case of naming conventions, it offers a set of properties around name and schema, and you can do the same kind of naming operations around that facet. And of course, these facets can then now be applied to different set of targets within your system, whether it's a database, whether it's a table, or whether it's a schema, etc.
Ram, can I interrupt you for just a moment?
Yeah.
Do you mind if I go ahead and launch the survey before you continue with the
Yes,
question?
you may. Sorry.
Okay, that's fine. So just a quick reminder that you will be eligible for a Microsoft Zune digital media player for completing the survey. And I will launch that now. You should be seeing it showing up in your slide area. All you need to do to complete it is click on those links that you see in the middle of your screen. We do appreciate your feedback. It helps us to improve our future webcasts. And with that, I'll hand the floor back over to Ram.
Thank you. So there are three questions around the last demo I walked through on automatic page recovery. So in concept, what we have done here was basically we simulated a corrupt page in the principal, and what that triggered was when we executed the first select statement, we actually saw. Let me bring up the demo. I think the demo is still available.
Actually, once we launch the survey, we can't go back into the demo.
Okay.
Sorry about that.
So let me then talk to it then. So in this scenario, what happened was the principal, we simulated a data storage corruption in the principal, and then when we executed the first select statement to retrieve information from the principal, it told the database, hey, there's now a corrupt page. And so within using mirroring automatically goes and checks with the mirrored database to see if that page is not corrupt in the mirror, takes the valid page from the mirror and overwrites the corrupt page in the principal. And so this is, and then so basically, so that was, and you can automatically, so you can now fix the corrupt page automatically from the mirror. I think I answered a couple of other questions. There are a couple of let's see. One of the questions is, what are the enhancements in bulk insert and BCP? We are making significant investment. We continue to innovate on bulk insert and BCP. I don't have the exact set of features that we're doing there, but we will be updating white papers on the links I given before, giving you more information around these two areas. Okay. One of the questions was, how do we get better error messages? This is something that we can take in to the product teams. I think we're continuing to deliver better set of error messages, so users have access to what information, why a certain policy failed. We'll continue to innovate and make sure we provide a comprehensive set of error messages for the end user. There's quite a series of questions, and what I will do now is actually I'll take these questions and I will add it, and I can respond. Sorry. Where the live meetings on new SQL Server 2008 features. These live meetings are actually available on the links I showed around the around next steps. So you can actually, if you go to www.microsoft.com/SQL, you can actually see a future version tab. If you click on that, that should direct you to the webcast and live meetings in this area. All right, that's all I have today. Again, I encourage you to please take the survey, and thanks for attending the session. Thank you.
All right, thank you so much, Ram. And I also wanted to mention that if you do want a copy of the slides, as a good way to get that next steps slide, you can go up to the File menu and select the Print to PDF option. Also, watch your inbox tomorrow for an email with information about viewing this webcast on demand. The email will also include a link to a downloadable PowerPoint of today's webcast. And at this time, I would like to extend a special thank you to Ram Ramanathan for today's presentation. Thank you all for joining us today. You may now disconnect from the audio portion of today's conference.